Hello, I am Arko Prabhadev. Today I will teach you an interesting Java program which is number related Java program, and that Java program is Dudeney number. First you have to know what is a Dudeney number. I am giving you an example. Example 512. You observe this number and now you extract its digits. Then you calculate its sum. What you will get? You will get 8. From this number you will extract its digits and then you will do the sum of these digits. Then you will get 8. Now do the cube root of this number. If you do the cube root of this number, you will get the similar number, that is 8. So then you will give a conditional statement that if the sum of the digits will be equal to the cube root of the number, then you will print it is a Dudeney number. So now let's write the program code. How will you execute? So let's name this program with initializing class named Dudeney number. First we need to initialize the class with a number, with a name, and there should not be any blank space. If you want to give a space, then you have to write an underscore. Okay, or you can write it together, or you can simply write it Dudeney. So I have initialized the class. Next I will initialize or declare a public class with void return type. A public class with void return type, and then I will input an integer type number int n. These are the basic syntax of doing a number related program. Now we will begin with the logic. Now we need to find the cube root of this particular number. So when we will write int cube root, and you notice it very carefully, I have declared the data type to be int. So as it is int in the left hand side, so on the right hand side of the equals to sign, the result should be also in the int data type. So first I have mentioned int. Now you see, if you get a number, a perfect Q number, for example 64, 27, 125, then if you find the cube root of that number, you will exactly get an integer number. But if I give you a number, for example 20, and I have told you to find the cube root of that number, then it will be a hectic task to perform. So in that case your answer will not come in integer data type, and it will come in decimals. So in that case, to avoid the decimals, I will use the math.round function in order to round up the value to its nearest integer that I have specified earlier. Now I will write the function to find the cube root, math.cbrt of that number, and then I will end. As there was lack of space, so I erased this. I am writing it here. Okay, so we have written the statement in order to calculate the cube root. Next what we will write? Next we will write the code to find the cube of this cube root. Suppose you are given a number 27. Now you have found the cube root of the 27 to be 3. Now when you are again trying to find the cube, then you will multiply the cube root 3 times, means cube root into cube root into cube root. So I will do that similar thing. Cube root into cube root into cube root. So I have ended the statement. Now what do we have to check? Now we have to check if the number is equals to the cube. if the number is equals to the cube, then we can satisfy that it is obviously an integer number, and we can proceed further with our calculations to check whether it is a Dudeney number or not. If it is not coming, that the number is becoming not equals to this cube, then we will become sure that the result is not coming in integer data type, it may come in decimal. So any decimal number can never be a Dudeney number, so we will write it is not a Dudeney number. So here we will give a conditional statement. If the number is double equals to cube, if this is possible, we will proceed with the calculation, else we will print not possible, that is not a Dudeney number. What does it mean? N is the number, cube is the cube root. What I have taken, always visualize the dry run. What I say, it is the dry run. Always during program visualize the dry run. What I have done, see, I have found the cube root of this number. The cube root of this number is 8. Now when you further find the cube of this cube root, then you will multiply 8 into 8 into 8, and further you will get 512, which is your original number. So in this case, whatever the number you have inputted is equal to the cube. So then we can proceed with our calculations, and then we can become obviously sure that the cube root is an integer. So now let's proceed with the calculations. Okay, so let's input int s equals to 0 and int d equals to 0. This variable I have initialized, int d I have initialized in order to store the digit after using the digit extraction loop and after extracting the digits from this number. Okay, to store the digit I have initialized this variable, and to store the sum of those digits I have initialized this variable int s. So now we will write the loop. We will write the loop for int I will be equals to n, I will be greater than 0, I will be divided equals to 10. This is the loop for digit extraction. If you perform this loop, you will get the required credentials for performing the digit extraction. So after writing this loop, we will extract each digit, that is the formula is d equals to I mod 10. Okay, so now you visualize it very carefully. I have taken a number, this is dry run, okay, and dry run is very important for programming skills. 512. See, how can you extract the digits 2, 1 and 5 separately from this number? To do this, you calculate mod division by 10. So if you perform this, it will come 1. So see, you are getting, if you write 512 mod 10, it will always give you the remainder. So you get 2, and 2 is your last digit. You have calculated the last digit. Now exclude this 2, 51. Now you do 51 mod 10. Similarly, what will you get? 551. So now you are getting the remainder 1. So this is the result 1. And now if you observe very carefully, 1 is your second digit. So thereby you can separate both the digits. And the remaining thing is 5. So again you do mod by 10 and you will gradually get 5 only. Just see, 10, 5, 0. So you are getting 5. Okay. So this is the simple logic. This is the logic of digit extraction. This is mathematical representation, that is dry run, and it is this is programmatic representation. Okay. Now I will calculate the sum. S will be plus equals to d. Calculated the sum. Next I will end the loop. Now I will give the conditional statement. Okay. Let's give the conditional statement. If this S means the sum is equals to the cube root, because if you observe it very carefully, you see whatever you had found the cube root, that is only the sum of the digits of that number. So if the sum of the digits of that number will be equal to the cube root of that number, then only we can uh, print the statement that it is a Dudeney number, else we will print it is not a Dudeney number. Okay, so let's print system dot out dot println n plus is a Dudeney number. Close this bracket and write else system dot out dot println n plus is not a Dudeney number. You close this bracket. But if you observe it very carefully, the if you had started here has ended with the else, if else structure. But the if you had started here has not yet ended. So you will require another else for this particular if. Okay. So here you will write else system dot out dot println n plus is not a Dudeney number. And here we conclude the program by closing the bracket of this else, by closing the bracket of this public void class, and thereby by closing the bracket of the class. But still we have not concluded. Actually we did this program using for loop. Now let's do this program using while loop. So for this I will make just a few changes. Okay, just a few changes. Only this part is required to be changed. For doing the program with while loop, I have to initialize another variable. Okay, so let's initialize it from the beginning. Int s will be equals to 0, int d will be equals to 0, and int n, and let's initialize another variable int I will be equals to 10, because while doing the calculation in while loop you need to initialize the variable at the first, but in for loop you can initialize it on the loop inside the loop only. Now let's do the calculations. Let's start the loop while I greater than 0. This is the condition. Next you write digit extraction, d equals to I mod 10, s plus equals to d. Done. Finally you have to give the iteration. Okay, so what is that? I divided equals to 10, and here we conclude our loop. This is the program using this while loop. The only difference in while loop and for loop is, in for loop you can initialize inside the loop only, and you can write this iteration statement inside the loop only. But the difference in while loop is that you have to initialize it before writing the loop, and you have to write this iteration statement at the last, just before ending the loop. This is the structure. Just have a look. This is the dry run. So dry run is very important to complete a program, and this is how I did the program. Thank you.